Hello guys, I am Nitishri S. Bagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we discussed regarding the image formation through the convex lens, and we discussed different cases, how the position of an object changes and how it affects on a position of an image. We discussed four cases, especially at infinite distance, near to the center of curvature, then after that equal to the twice of the focal length and near to the focal length. And also today we are going to discuss two more cases regarding the image formation of the convex lens. Then we are proceeding to the concept of image formation through the concave lens. Okay, let us begin now. So in the last class, as I said you, regarding the image formation through the convex lens, today we are going to take the case at f2. At f2 means at the focal principal focus. If an object is placed at the principal focus, what will be the position of an image? How the image will be formed? What will be its nature? So let us see. Let us consider an object OJ, as you can see, and let us consider two rays of light from OJ. One ray of light is parallel, is incident parallelly. One ray of light is incident parallelly to the principal axis and it meet the principal axis at the principal focus, that is F1. Next, one ray of light we will consider which will pass through the optic center, and we know that there is no deviation when a light ray passes through the optic center of a lens. So when you see these two rays, these will not meet. The refracted rays run parallelly to one another. These two rays are running parallelly to one another. Then where the image will be formed? We can say that the image formation takes place at infinite distance. So when we place an object at the principal focus, the image formation will be at infinite distance, but the image formation takes place. That is why the nature of image is real, inverted and highly magnified. Means it will be very larger in size compared to an object. It can be caught on a screen and inverted. In the last session, in the last point of the last session, I said that the image formation will be virtual. No, it will be real, but it is at the infinite distance. There will be a confusion whether it is virtual or a real. But the correct term is the nature of image will be real, inverted and highly magnified. Then the next case is when an object is placed less than the focal length. Lowercase f represents the focal length. That is the distance between the optic center and the principal focus. So this is a focal length. Okay. This distance is a focal length. An object is placed in such a way that it is near to the optic center and near to the principal focus, but less than the focal length. So then also we will consider two rays of light. One is traveling parallel to the principal axis, the other is traveling through the optic center. So when we see, we will get the refracted rays which are moving apart from one another, Then where the image will be formed? So for that, what we will do, we will extend or we will drag these refracted rays. Okay, we will drag these refracted rays in such a way that we will get a point behind the lens where these refracted rays appear to meet. That is the point where an image will be formed. So when you see the size of the image, you will get to know that the size of the image is highly magnified. Magnified means the size is very large. The height is very high than compared to an object. So the nature of image here will be virtual. It will not be caught on a screen because it is formed behind an object, on the object side only. Then erect, then highly magnified image. So this is the nature of an image through a convex lens. This is a special case and important. Fine. Now, let us consider the image formation through the concave lens. So we know that in the concave lens, we will be having two spherical surfaces which are bent inwards. And we know the concave lenses are the diverging lenses. Means the refracted rays through the convex lens will diverge from a single point. So that single point from which these rays will diverge, that point is considered as a principal focus of a concave lens. So let us begin. So let us keep an object at an infinite distance from the lens, and let us consider an object is emitting or incidenting parallel rays of light on the lens. So when the parallel rays of light are incident, the refracted rays will be in this direction. They are spread. They are diverged. So when we drag back these refracted rays, we will come to know that these will meet at a point. So that point is a principal focus, and that is the point where an image will be formed. And the image formed here will be at the principal focus, and it will be very small or very diminished, means very smaller size image. So that is why the image will be considered as a point image here. The nature goes like this. The image will be pointed, erect. It is not upside down. It is straight only. Then virtual. An image will not be caught on a screen. The next case, when we take an object nearer to the concave lens. So let us take an object nearer to the concave lens beyond 2f2. Okay. So beyond 2f2. So here what happens? An object OG is placed, and we consider two rays of light. One is running parallelly, other is running through the optic center, and we will get these refracted rays. So when we get back these refracted rays like this refracted rays meet at a point. So this point is where an image is formed. So you can see that as an object is coming nearer to the lens, an image is also formed nearer to the lens. Object distance, as it decreases, the image distance is also decreasing from the lens. And here an image is diminished but not point. It is smaller in size, but it is not a point image. So here the nature of image will be diminished, erect and virtual. So in all the cases, if we take an object on the twice of a focal length, if we take an object nearer to the principal focus, at the principal focus, we will be getting an image which is nearer to the concave lens. So at certain point, we will get a very magnified image because it will be very closer to the lens. So this is the nature of images through the concave lens. So here we completed how the images will be formed through the convex as well as concave lens. In the upcoming session, we will be dealing with certain formulas which are related to the lens, and we will be solving certain numerical problems. Until that, learn science, observe science. Have a nice day.